Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ordinary differential equations, and in particular we are going to look at the Taylor series method. Now we have this question. We are asked to use Taylor series method to solve the initial value problem dy over dx is equals to x plus y, subject to the condition that y of 1 is equals to 0. Solve it numerically up to x is equals to 1.2 with the step size h is equals to 0.1, correct to 6 decimal places. So let's see how to go about this problem. Remember, we are using Taylor series method. And the general formula for the Taylor series method is that yn plus 1 is equals to yn plus h yn prime plus h squared over 2 factorial yn double prime plus h cubed over 3 factorial yn third prime plus h raised to 4 over 4 factorial yn the fourth derivative plus so many other terms. Up to infinity. Remember, the derivation of this formula, you can find it from my PDF notes. It is based on Taylor series expansion of y of xn plus 1 about xn, so that we get this formula. Now, n ranges from, you can say, where n is equals to 0, 1, 2, 3, etc. I want us to take note that when I write yn, it is the same as y of xn. When I write yn plus 1, it is the same as y of xn plus 1. And remember, xn plus 1 is the same as xn plus h. This plus 1 should be somewhere here. This is the n that you're adding 1, n plus 1. When we talk of xn plus 1, it's the same as xn plus h. H here is the step size. Now look at our initial condition that y1 is equals to 0. So the one there is our x naught, and so that means our y naught is equals to 0. So we are given that x naught is equals to 1, y naught is equals to 0, and dy dx, which is, we can write as y prime, is equals to x plus y. Y prime is dy dx. Also, we have the step size, h is equals to 0.1. So we want to iterate it up to x is equals to 1.2. So we have something like this. Let me draw it here. Here we have x naught, x1, x2. Here we'll have y naught, y1, y2. What is the value of x naught? It is 1. The step size is 0.1, so we go to 1.1. Then we go to 1.2. So we want to go up to 1.2. I know the value of y naught to be 0. I don't know y1. Neither do we know y2. So we need to find y1 and y2. Now, if you look at our ODE, we can get this or simply write as subscript n. So this can as well be written as yn prime. We evaluate the ODE at xn. That's what I'm doing. Is equals to xn plus yn. So when you evaluate it at xn, you get what I've written here in blue. Now, let's now get yn prime. Double prime, I mean. I'm going to differentiate this so that y double prime is equals to, we are differentiating with respect to x, so derivative of x will get 1. The derivative of y is dy dx, which is y prime. Again, if you evaluate at xn, we'll get yn double prime is equals to 1 plus yn prime. Proceed. Remember, we have up to the fourth derivative, so I'll need to get the third derivative. Third derivative, when you differentiate 1, you get 0. So that is 0 plus y double prime. When you evaluate this at xn, we are going to get y third prime of at n is equals to yn double prime. And finally, the fourth derivative, y fourth derivative, that is the third derivative. Evaluate this at xn, we are going to get yn fourth derivative should be able to give us yn third prime. Now we know x naught, we know y naught. Those are the starting values. And we also know h. So if I want to find y1, I'm going to put n is equals to 0 in this iterative formula. Let me bracket it. This is the formula that will guide you to find the missing values of y, or the missing functional values. So let me call it equation star. And then you say, put n is equals to 0 in equation star. Put n is equals to 0 in equation star to get, when we use 0, we are going to get y1 is equals to y naught plus h y naught prime plus h squared over 2 factorial y naught double prime plus h cubed over 3 factorial y naught third prime plus h raised to 4 over 4 factorial y naught fourth derivative. Remember, it is an approximation, so whatever is missing is the error term. So these are just approximation. Now we need to find y naught prime, y naught double prime, all the way up to y naught fourth derivative. So let me work it out here. Y naught prime, from these derivatives, we get them from here. Let me bracket these ones. From there, y naught prime is the same as x naught plus y naught. Our x naught is 1, our y naught is 0, so the result there is 1. Y naught double prime is 1 plus y naught prime. That is 1 plus, our y naught prime is 1, so the result there is 2. Y naught third prime. From there, remember we are using n is 0, so that's the same as y naught double prime, which is the same as 2. And finally, y naught fourth derivative is the same as y naught third prime, which is 2. So having found those, we replace them in this formula for y1, and then you press in your calculator. So this is what you're going to do. This will now be equal to our y0 is 0, our h is 0.1, y0 prime is 1, again 0.1 over 2 factorial, which is 2, y0 double prime is 2. Remember, it was h squared, so this should be squared. Here we have 0.1 cubed over 6, which is 3 factorial, times y0 third prime is 2, plus 0.1 raised to 4. 4 factorial is 24. Y0 fourth derivative, that is 2. So when you press this in your calculator, let us see what you're going to get. If you do it, you need to get 0.110342. 0.110342. That is correct to 6 decimal places. So I'll bracket this. This is our y1. And what do you mean by y1? Take note that when we write y1, it is y at x1. And what is our x1? It is 1.1. So this is the same as y at 1.1. That's what it means. And the value is that one. So we have found the first one. Now we need to find y2. If I need y2, what I'm going to do is to substitute n is equals to 1 in equation star. So you can write this, that put n is equals to 1 in equation star to get, that will now give us y2 is equals to y1 plus h y1 prime plus h squared over 2 factorial y1 double prime plus h cubed over 3 factorial y1 third prime plus h raised to 4 over 4 factorial y1 the fourth derivative. Remember, there are other terms which we are neglecting. We are approximating up to the fourth order term so that the missing terms will constitute the error term. So we need to find y1. Of course, we have y1 already. So we need to get y1 prime, y1 double prime, all the way up to y1 fourth derivative. So again, I'm going to calculate them here. Here, we still use these derivatives. Now in this case, n is 1. When you put n is 1 here, you're going to get all those derivatives. So we start with y1 prime. So right here, y1 prime is the same as x1 plus y1. Our x1, what was it? It was 1.1 plus our y1, we have found it here, this one. That was 0.110342. And if you press this in your calculator, that should give you y1 prime as 1.210342. Proceed to get y2, y1 double prime, I mean. So if you look at our derivative up here, y1 double prime will give us 1 plus y1 prime. So that's what I write here, is equals to 1 plus y1 prime. And so this is the same as 1 plus y1 prime. We have found that to be 1.210342. When you add, you get 2.210342. Proceed y1 third prime. Look at our derivatives. Y1 third prime will give us y1 double prime, the same as y1 double prime, which we have found 2.210342. And finally, y1 fourth derivative is the same as, look at our derivative. When n is 1, we get y1 third prime. So that's the same as y1 third prime, which we have found to be 2.210342. So now we have those values. Let's substitute them back into the formula for y2. So we can now say that therefore our y2 is equals to y1, which is 0.110342, plus h, which is 0.1, times y1 prime, we got 1.210342, plus h squared, that is 0.1 squared, over 2 factorial, that is 2. Y1 double prime, we got 2.210342, plus 0.1 cubed over 3 factorial, that is 6, times y1 third prime, we got 2.210342, and finally 0.1 raised to 4 over 4 factorial, which is 24, times y1 fourth derivative is the same as 2.210342. So press this in your calculator. When you do it, you need to get 0.242. Let me write it here. 0.242806. Correct to 6 decimal places. So this is the value of y2. And what is the interpretation of y2? When we write y2, what does it mean? It means that, take note that y2 is the same as writing y of x2. And that's the same as our x2 is 1.2. So that's the value of y at 1.2. So we have found the other value. You can just say, or y2 is equals to this. Remember, you could proceed all the way up to yn. But depending on the question, we are told to go up to x2, which is 1.2. So we have found the missing values, is y1 and y2. Now that's how to use Taylor series method to approximate solution to a first order ODE. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of ODEs. Bye-bye.